This is Euclid Book 8, proposition number 5, and once again, as I show you this little diagram, go ahead and pause the video. Okay? Here you go. Now, some of the information that you're going to be presented here tonight, you will probably remember from some previous books. Okay, these are books of Euclid that I'm talking about. Some previous proofs of Euclid will come back to your mind while doing this. All right. Let's read this, shall we? Plane numbers have to one another the ratio compounded of the ratios of their sides. Let A and B be plane numbers, and let the numbers C and D be the sides of A, and E, F of B. Okay. I say that A has to be the ratio compounded of the ratio of the sides. I bet you're thoroughly confused at this point. Let's just go on real slow here. 4. The ratios being given which C has to E and D has to F. Okay, now let me show you this. There is a ratio of C to E. There is another ratio of D to F. Okay, the ratio of C to E is not the same as the one from D to F. And I'll show you that in just a little bit. Okay. Let's continue. Let the least numbers, I'm sorry I stuttered again, let the least numbers G, H, and K that are continuously in the ratios C to E, D to F be taken so that as C is to E, so is G to H. Let me show you this. As C is to E, so is G is to H. Okay? So these two lines are in the same ratio as these two lines. Let's go on here. As D is to F, so is H to K. So as D is to F, so is H is to K. Okay, got that so far? This is by Euclid Book 8. Hold on. Proposition number 4, which is the last proof we did. And let D by multiplying E make L. D times E makes L. Okay. Now since D by multiplying C has made A, oh boy. If you multiply this times this, you'll get this length right up here. Let's go on. Now, since D by multiplying C has made A, which we just talked about, and D multiplying E has made L, okay, when we multiply this times this, we get this. This times this makes this. Let's go on here. Therefore, as C is to E, so is A to L. And this is by Euclid Book 7, proposition number 17. All right. So as this is to this, so as this is to that. So these two are in the same ratio as these two. Wow, that's a lot right there. Okay, let's go on here. But as C is to E, so is G to H. Therefore, also as G is to H, so is A to L. Okay. As G is to H, so is A is to L. These two and these two are in the same ratio. Okay, let's go on. Again, since E multiplying D has made L, and further by... Okay, whoa. Alright. E times D makes L. E times D makes L. Okay. And E times F makes B. Okay. E times F makes B. All right. Slow and steady now. Therefore, as D is to F, so is L to B. As D is to F, so is L is to B. Okay, so these two are in a ratio, and these two have the same ratio as these two. Wow. And this is by Euclid Book 7, proposition number 17. But as D is to F, so is H to K, which we established previously. Therefore, as H is to K, so is L is to B. As H is to K, so is L is to B. This is in a ratio. This is in the same ratio. Okay. I'd like to see one of you guys try to put this with real live numbers. I think it'd be very interesting. But it was also proved that as G is to H, so is A to L. Therefore, xi quali as G is to K, okay, as G is to K, so is A to B. And this is by Euclid Book 7, proposition number 14. So, as G is to K, so is A is to B. So these two are in the same ratio as these two. Okay, let's go on here. But G has to K the ratio compounded of the ratios of the sides. Therefore, A also has to B the ratio compounded of the ratio of the sides. And that is the end of the proof. Wow, what a proof, huh? If you guys want to stick numbers in any of this, you go right ahead. I'd love to see you try it. Alright, I will tell you more in a future video. Stay tuned.